This is the test 4 review for stats. Okay? Test 4 review for stats. All right, so here's what I've done. As you can see right here, I marked that one out. I have several marked out throughout here. I'm only going to work the ones that are on the test. Not optimal, but that's what I'm going to do. Identify the sample space in the probability experiment tossing a coin. You toss a coin, you have a set, and in that set you either have heads or tails. And it may have heads written out and tails written out, I don't know, but that's all you have is heads and tails. There's nothing else that you can get, all right? So that is your solution set. This should be 1 pound bag right here. That should be pound in a 1 pound bag of Skittles. You have red, green, yellow, orange, and purple. Is this thing a probability model? Well, first of all, are all of these in between 0 and 1? And they are. Then the other thing is we need to add them up. So we need to take 0.2227, 0.1908, 0.2164, 0.1885, and 0.1816, and add all those together. Add all those together. So I'm going to take my calculator and I'm going to say 0.2227 plus blah, 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 blah. And I hit a wrong button, so now I'm having to fix it, which takes forever. And that equals 1 exactly. So 1.0000, whatever you want to say, is exactly 1. So I'm going to say yes, this thing does represent a probability model. So skipping over number 3. Number 4, in terms of probability, A or M blank is any process with uncertain results. That is going to be an experiment. An experiment, okay? An experiment. And let me say this too about skipping number 3. The ones that I skipped are included in the PDF file that is posted in the modules under Test 4 Review Files and Videos or something like that. There's a page there that says that where this video is linked and that kind of thing. And on the review, number 3 is not marked out, and the answer is there on the last page. The last page is the answer to all of them, actually. So you can even make sure I got the same answer that the test bank got, because I gave you the answers. All right, the next one, use the spinner below to answer the question. So you have 1 through 5 marked on the spinner, and what is the probability that it lands on 3 or 1? Okay, what's the probability it lands on 3 or 1? Well, 3 or 1, and they can't happen at the same time, so you just add them together. What chance is it that you get a 3? 1/5. Plus, what's the chance you get a 1? 1/5. So 2/5, or you can count them. How many possibilities are you? How many possibilities work out for you? 2. How many total are there? 5. So 2 out of 5 is the chance that you get a 3 or a 1. So number 6, you are dealt a card from a standard 52 card deck. Find the probability of being dealt an ace or a 6. So let me go ahead and just pull this up real quick. Just take a second to pull this up. Stats, handouts. And then I have this, and I actually put this out there for you as well. Here's an image of all 4 suits. You have your spades at the top, your hearts next, your clubs. Looks like a 3-leaf clover, right? And then you have the diamonds on the bottom there. Each one of them goes ace, which is like a 1, 2, 3, 4, 5 up to 10. You have jack, queen, king. And then you have your sides of your fair die below that, 1, 2, 3, 4, 5, 6 with the dots. And so if it's a fair die, it has an equally likely chance of happening. So on this one, we are asked for the probability of being nothing, ace or a 6. Well, if we look at it, we have on the left-hand side 4 aces, and if we look at 6s, they're sort of in the middle, a little bit to the left of center. There's 4 of those. So we have 4 out of 52 that we get an ace. All right. So here, the probability of an ace is 4 out of 52. The probability of getting a 6 is also 4 out of 52, and they can't happen at the same time. So the probability of ace or 6 is just add them together. Okay. probability of ace or 6 equals the probability of ace plus the probability of a 6. Okay? So that's going to be 4 out of 52 plus 4 out of 52, which is 8 out of 52. And 8 and 52 both divide by 4, so we end up with 2 out of 13. Okay? This is also the same thing as 1 out of 13. We could have done that up here on both of these and then gotten 2 out of 13. All right? So 2 out of 13, 6 is A. Okay? You have a 1 out of 13 chance of an ace, 1 out of 13 chance of a 6, or 4 out of 52 for each one. You add those together because you can't get an ace and a 6 at the same time. A die is rolled. 1 through 6 is equally likely outcomes. Find the probability of getting a 10. Find the probability when you roll a die of getting a 10. Well, that ain't happening. It's impossible. Why is it impossible? Because you can only get 1, 2, 3, 4, 5, or 6. You can't get any other number. So 10 is impossible. All right. There's that one, that page. Here I've marked out a couple of them. And you'll see that each page I turn, I mark out some. So I think every page has some marked out anyway. All right. So number 8. Or it's not really number 8 now, but anyway. The sample space for tossing 3 fair coins. 3 heads, 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 tails, heads, tails, heads, heads, tails, tails, right? All that stuff. What is the probability of exactly 2 heads? That means we want all of them with exactly 2 H's in them. So if we look at this, with exactly 2 H's, we don't want this one that has 3 H's. That has 2 H's, that has 2 H's, that has 1 H, that has 2 H's, that has 1 H, that has 1 H, and that has no H's. So we had 3 ways it could work out for us out of how many, right? We have 1, 2, 3 ways it could work out. And then we had a 4th option, a 5th option, a 6, a 7, and 8 if we count them all, right? So 3 out of 8. 3 out of 8, which is C here. C for number 8 here, which again is not really number 8 anymore because I've taken some out. But 3 out of 8, right? To get exactly 2 heads. What is the probability of getting an odd face up? So you roll a die 50 times. This is empirical, right, where you do an experiment. Okay, and odd face up. Well, odd faces are this one, and this one. You can't get 1, 3, or 5 at the same time, right? It's one or the other. So you just simply add them up. This is 0.22 plus 0.18 plus 0.18. So that should be 0.58, 0.58, which is B. So then B for that answer. You just add them up. They cannot happen at the same time. If they cannot happen at the same time, you simply add the probabilities together. If they can happen at the same time, remember you add each individual probability and then you subtract the and away from that. A card is drawn from a standard deck of 52 playing cards. Find the probability that the card is a queen or a club. Okay, so here, a queen or a club. Let's look at my cards here. Queens are on next to the right, the second from the right column. There's 4 queens. And then it says or what? Queen or a club. A club. My clubs is the 3rd row here. There's also a queen of clubs, right? There's a queen that is a queen. So you have 4 queens, and then you have 13 clubs, and you have 1 card out of all 52 that's both a queen and a club. All right? So that's important here. So what we're going to do for number 11, what we're going to do here is we're going to say that the probability of a queen or a club, all right, is going to be the probability of a queen plus the probability of a club minus the probability that it's a queen and a club. All right? So we said that was 1 out of 52 cards here for a queen and a club, right? I can't write. 1 out of 52. And then the probability of a club was 13 out of 52, and the probability of a queen was 4 out of 52, right? There were 4 queens. There were 13 clubs, and there was 1 card that was both. So 4 plus 13 is 17, so this is 17 minus 1 over 52, which is 16 out of 52. And again, 4 goes into both of these. 4 goes into 16 4 times and 52 13 times. So 4 out of 13 is how many, or your probability of getting a queen or a club. So A, 4 out of 13 for that one. And it's more important that it's 4 out of 13, not that it's A. All right, so find the probability that you are not dealt a spade. What? All right, so this is the idea. This is the idea of complements, okay? So the probability that it is not a spade, okay, is equal to the probability of, what was a spade? Oh, yeah, spades. I can't draw a spade. Probability that it's a spade complement, okay? Not a spade. So that's going to be 1 minus the probability that it's a spade, okay? Can't draw it, but anyway. How many spades are there? Well, the top row of spades, there's 13 cards up there, 13 spades out of 52 total. So this is 1 minus 13 out of 52, but we also said, look, this is really 1/4. 1/4 of the cards are spades, 1 row out of 4 rows. So this is 1 minus 1/4, which is the same thing as 4 over 4 minus 1/4, which is 3/4. All right, so 3/4 for 12 here. 3/4 is the probability, which is B, that you draw a card that is not, or you're dealt a card that's not a spade. Two events are what if the occurrence of event E does not affect the probability of event F? They're independent. 13, they're independent here, okay? They are independent if one does not affect the other. If you have independent events and you want to know this and the other, if they don't affect each other, you just multiply the probability of event 1 times the probability of the other event, and boom, you get the probability of one and the other. So a single die is rolled twice. What's the probability of getting a 6 first and a 2 the second time? So the probability of getting a 6 first and the probability of getting a 2 the second time, right? So a 2 is 1 out of 6, a 6 is 1 out of 6, and the probability of getting a 6 first and then a 2 second is going to be the probability of a 6 times the probability of 2. Because if you roll the die once and pick the die out and roll it again, what the die did the first time doesn't affect what it does the second time. It's a fair die. It's got a 1/6 chance each time you roll it. So this is going to be 1/6 times 1/6, which is 1 out of 36. Okay? 1 out of 36. So 14 here. Again, it's not really our 14th one we've done, but anyway, it's D. Let me see. Fix that mess. It's D. All right. You toss a fair coin 5 times. What is the probability of at least 1 heads? Okay. So the probability of at least 1. All right. The probability of at least 1 head. So that's, you get 1 head, you get 2 heads in a bunch of different ways, you get 3 heads in a bunch of different ways, 4 heads in a bunch of different ways, or 5, all 5 of them are heads. So the only thing that doesn't include is if you get no heads, right? So what this is the probability of 0 heads complement, okay? It's the complement of getting no heads, okay? None. You get 5 tails. So this is 1 minus the probability of no heads, right? Which is the same thing as 1 minus the probability of all 5 tails. Well, what's the probability of all 5 tails? Well, again, we multiply independent events. If I flip a coin and get tails, when I flip it again, does the coin remember it got tails and try not to get tails this time? No, it doesn't. It's a 1/2 chance every time. So this is really 1 minus, and this is going to be 1/2 times 1/2 times 1/2. How many times? 5 times, that's right. Because tails, 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 tails. So that's really 1 minus 1/2 to the 5th. So it's going to be 1 minus 1 over 32. So it's going to be 31 over 32. And if I take my calculator and do 31, or I can actually just type in 1 minus 1/2 to the 5th as long as I do that part right. But 1 minus 1 over 32, if I enter it in correctly, 31 divided by 32 is 0.96875. But it goes to 4 decimal places, so 9,688. Okay? 9,688. All this was for 16 over here. Okay? So I showed you a little bit more maybe than could have talked you through more of it maybe, but there, wanted to show you what we did there and how we got that. The managers of a corporation surveyed. This is all blah, blah, blah. Each manager was good, fair, poor. What really matters is, look at this given statement down here. Given that a manager is only fair, right? Here's fair. So I really only care about this row right here. Okay? Given that they're fair. I don't care about good and poor managers or totals. What is the probability the manager has a college degree? So college degree is 42 out of how many? 42 out of 87. Now, when I look up here, I don't see 42 out of 87, so I have to go, well, I wonder if this thing simplifies. So if you have the math frac button on your calculator, you can math frac it, or you can sit here and go, let me try to divide some things out. If you quickly look at this, 4 plus 2 is 6 if I add the digits. 8 plus 7 is 15. 6 and 15 are both divisible by 3, which means 3 goes into them. If you don't know that divisibility rule for 3, if you sum the digits, 42, 4 plus 2 is 6, 3 goes into 6, therefore 3 goes into 42. 87, 8 plus 7 is 15. 3 goes into 15, so therefore 3 goes into 87. It doesn't tell you how many times, but that's a probability, a divisibility rule. So this is going to be 42 divided by 3. Right, if I divide out a 3 over 3, then this is going to be 14. 14 times 3 is 42, and then 87 is going to be 29. So 14 over 29, which I do have, is answer C there for 17. 18, the conditional probability of an event G. The conditional probability of an event G, given that H has occurred, is written as what? P of G given H, right? G given H, which is D there, right? The G comes before the vertical line. The probability of event G given the fact that we know H has already occurred. All right, number 19. A bag contains 10 white, 12 blue, 13 red, 7 yellow, and 8 green. All right, wooden balls. A ball is selected from the bag and you keep it. This is mean not replacement. Then you draw a second one. What's the probability that they're both blue? Well, how many blue ones did we start with? 12 out of how many total in the bag? Well, I don't know. I have to add it up. So I have 10, 12, 13, 7, and 8. So 10 plus 12 is 22, plus 13 is 35, plus 7 is 42, plus 8 is 50. Okay? So 50 total, so 12 out of 50 for the first ball to be blue. And then what about the second one? If I don't replace it, I have how many left? 49. And how many blue are left? 11. So then I have 12 over 50 times 11 over 49. And then I say, okay, can anything divide out? Well, obviously 2 goes into both of these, 6 and 25. But outside of that, I don't know what else might work. And I'm going to get a decimal anyway. So I'm going to multiply that together. I'm going to get 6 times 11 is 66. And then 25 times 49. 66 over 1225. 66 over 1225. Or if you didn't take the 2 out, you would have gotten 132 over 2550, I think. Let me just do that. 12 times, well, if I can type it in my calculator right. Yeah, 12 times 11 is 132, and 50 times 49 is 2450. I did that wrong. Okay, 2450. So then if I divide 132 divided by 2450, I get 0.0539 to 4 decimal places. 0.0539. And is that any of our choices here on 19? It is indeed A here. Okay, it is indeed A there. All right. And then evaluate the factorial expression. If you have the calculator in front of you, this is as easy as plugging it in. All right. So literally 8, and then you have your PRB menu, and you go to your factorial, divided by 6, and you have your PRB menu, and you go to your factorial, and you hit enter. Okay? If you don't have it, you can say 8 times 7 times 6 factorial over 6 factorial, and those divide out, and 8 times 7 is 56, right? So D, right? D for number 20 here, all right? And then don't skip over this last one on this page. License plates. I love these kind of counting problems like this, and I took several of them off, but I love these counting problems. License plates in a particular state display 2 letters followed by 3 numbers. How many different license plates can they manufacture? And repetition is allowed, so you could have AA or CC or QQ for your letters, or you could have 333 for your numbers, or 343, or any kind of repetition, 337. You could have repetition is allowed here. So I have 2 letters, okay? So let's start with that. Let's start with 2 letters, all right? 2 letters and then 3 numbers. So my 2 letters, I have 10 choices for the, I'm sorry, not 10. This is letters. 26 choices for my first letter, and I have 26 choices for my second letter, right? My first number, I have 10 for the first digit, 10 and 10. So this is really 26 squared times 10 to the third, which is going to be a lot. A whole lot, actually. 676,000 maybe. Let's see. 26 squared times 1,000. Yeah, that's what it is. So that's D. D should be the answer for number 22 here. D. 600. This is 676,000. 676 is 26 squared, and 10 cubed is 1,000. So then that's 676,000. All right. All right. So let's keep going here with this. True or false? 0 factorial equals 1 factorial. Well, remember they're both defined to be 0 factorial is defined to be 1, and 1 factorial is defined to be 1. So this is true here. 23B is true, all right, for 23 here, all right. How many different 4-letter secret codes can be formed if the first letter must be an S or a T? So again, I love this right here, this kind of stuff. So I have 4 letters, but the first one has to be S or T, which means it only has 2 choices. It doesn't say we cannot repeat things here. So then how many choices do I have for the next 3 letters? How many different 4-letter secret codes if the first letter, it just says that. So this is going to be 2 times 26 cubed. I don't know what 26 cubed is, y'all. I know what 26 squared is. Don't know what 26 cubed is. So somewhere I have a power button here for the cubed. So 35,000. Is that an answer? That's not an answer, is it? Yeah, it is. 24. So 35,152 of these things. So B, 35,152 of these secret 4-letter codes. If the first letter is an S or a T, because you only had 2 choices for the first letter and then 26 for each of the others. There is a button again on your calculator, NPR, so 10, NPR 6 for this, for permutations. And it's 151,200, which is A. Okay, literally plugging in. If you remember, the formula is going to be 10 factorial over 10 minus 6 factorial is 4 factorial. So we go 10 times 9 times 8 times 7 times 6 times 5 times 4 factorial over 4 factorial and divide those out. And if you do 10 times 9 times 8 times 7 times 6 times 5, you end up with 151,200. Okay, so 10 times 9 times 8. I'm just going to check it while I'm sitting here so that I didn't tell you the wrong thing. And that's what it is, okay? So if you remember, it's n factorial over n minus r factorial for NPR for the permutation, okay? So 10 over 10 minus 6 is 4 factorial, 10 factorial over that. For combinations, for 28, for combinations, it's a little different here. For combinations, we have n factorial over r factorial, n minus r factorial. That's going to be NCR. So this one's going to be 10 factorial over, that's 4. 4 factorial and then 6 factorial because 10 minus 4 is 6. So you got 10 times 9 times 8 times 7 times 6 times, 6 factorial, right? Over 4 times 3 times 2 times 1 times 6 factorial. So the 6 factorials divide out. There's not supposed to be anything there. All right. Then 4 and 2, get rid of the 8, and the 3 makes out of 3. So you end up with 10 times 3 times 7 times 6. So 42 is 7 times 6 times 3 is 126 times 10 is 1260. That doesn't sound right. Something's not right about that. Or is that the right answer? No, that's not the right answer. Let's say 10. Did I leave something out? 10. 4 times 2 is 8. 3 3 times 42. Let's see. Let me just punch it in my calculator because I'm confusing myself trying to talk through it. 10 choose 4 is 210. Where did I get 7? Oh, 6 factorial. I didn't need the 6. That was crossed out. I left the extra 6 in there. 7 times 3 is 21 times 10 is 210. I didn't even notice I had it marked out. That's where I went wrong. All right. So B for 28. B. No wonder I was confusing myself. I was like, that's not the right. This is not right. Okay. So I had marked out 6 factorial here, and I was counting 7 times 6 on the numerator. So I was messing myself all up. All right, this is actually the last one, because if I flip over here to the last page of the review, I wanted to wish you good luck, but I didn't choose any of these last 6 problems at all on the test, okay? I would love to have been in the room with you and been able to go over that with you, but on here, I'm just not going to do that. I'm sorry. You miss out on some of those counting techniques, but you can go through and try to figure them out using the formulas in the chapter about that if you want to, all right? From 9 names on the ballot, a committee of 5 will be selected. It doesn't look how many different committees are possible. It doesn't say that they're places. So, like if I'm chosen first or fifth, it doesn't matter. I was still chosen. So this is a combination. I'm going to use 9C5. I'm going to use 9C5. So that's 9 factorial over 5 factorial, 4 factorial. 9 times 8 times 7 times 6 times 5 factorial, and I'll try to remember this time. 5 factorial times 4 times 3 times 2 times 1. Those divide out. And 4 and 2 get rid of the 8, and that gets rid of the 9 to make a 3 again. So now I have 7 times 6 is 42 times 3 is 126, isn't it? Is that what that is? So let's punch that in my calculator and see if I have 9 combination. That's my PRB menu, right? And 5 is 126. So D 429 here. Okay, which I believe is our 23rd problem we worked there. I think there's 23 on the test. All right, I hope this helps out to see some of this worked and hear some of it, at least semi being explained, except for when I confused myself on 28 or whatever it was. Again, good luck, and hope that you do well on this test.